The question is, how do you build a learning machine? You know, a company is a very large machine, and you can't touch it all. And many of you work in much, much larger companies than I do. And you can't touch it all. You can't control it all. You can't control hardly any of it, in fact. And so how do you create this machine that is a living, breathing machine that somehow evolves over time, reinvents itself through continuous learning? How do you architect such a thing? How do you give it motivation? How do you inspire it to do the right things? How do you give it a sense of purpose? How do you make it a living, breathing thing that everybody in the company, all the employees that are part of it, knows what this machine is? But it's a living, breathing thing. So that's my talk. So NVIDIA, we started NVIDIA 23 years ago. We have 9,000 employees. We're largely engineering, about a $5 billion company. We're the largest computer graphics company in the world. We're the largest computer graphics company in the history of computing. We're the largest company of its kind. We're the best in the world at what we do. Frankly, we have no peers. Very few companies have ever endeavored this one field for this long and have led for this long. You might have seen some of our work. We're the platform of PC gaming. We make it possible for gamers all over the world to be suspended in disbelief, enjoy a virtual world. You might have seen also our work designing cars. Almost every single car company in the world uses our technology for styling their cars, for designing their car, the computer-aided design of the car, all the way through the entire supply chain uses our technology to make it possible for them to design their cars, and all the way into the inside of the cars now with infotainment. You also might know that our company's technology is used to power our nation's fastest supercomputers. In fact, we power the vast majority of the world's fastest supercomputers. And this is a technology use that was quite new, and I'll talk about that in a second. And recently, we invented a new type of computer. We call it the DGX-1. It's a deep learning supercomputer that is a computer that writes software itself. Okay, this is the beginning of a new phase in computing where it's possible for us to now have computers that write software by itself. And it's quite a miracle, and I'm going to show you an example of that. We build computers for the world's most demanding users. In fact, we don't build computers for everyone. We don't build computers for billions of people. We build computers for, if you will, the Da Vinci's, the Einsteins of modern world, so that they could make an impact on billions of people. We build computers for the most demanding users in the world. The type of demanding users, of course, one of them you probably have at home, a young gamer. It turns out a video game is one of the most computing intensive applications ever known. And it was our observation that a video game may be the killer app of future technology that really inspired the forming of our company. And it has been a technology driver for sure. It has made it possible for us to invest more in this field of computing than any company ever has. We modernized what we call computer graphics today. We invented the processor called GPU, and we invented a new type of computing called GPU computing. I'll show you an example of that. As the pioneer of GPU computing, we use this form of computing in two ways. These two ways both require nearly infinite amounts of computing. One way, one application of our technology is essentially simulating the virtual world. Inside a computer, recreating the world. You can imagine how complicated it is from a physics perspective, from this simulation of behaviors perspective, and of course, how it looks. Simulating light is a very complicated problem. This is a very large market. We enjoy it very much, and this is a field of work that has brought us great joy. The counter to that, the cousin of that, the flip side of that coin, if you will, is using exactly the same computing model now, not to simulate the world using a computer, but to understand the world using a computer. If the first form of use is called virtual reality, the second form of use would be called artificial intelligence. They're cousins, if you will, of the same computing model. Imagine if when you're thinking, if I said something like a place that I enjoy very much, I say Maui. When I say Maui, all of you now have somehow generated some images in your mind. You have done some computer graphics in your head. Some of you envision Maui as sandy beach, palm trees. The sun's usually setting when I'm there, and I love that time of the day. You see the ocean. So somehow you've done a very quick version of computer graphics so that you can think. If I asked you to imagine a beautiful building, what is your favorite painting? You've just done some computer graphics. So if you will, thinking is the cousin of computer graphics. We use the same computing model called GPU computing that affords us an enormous amount of capability to solve these two basic problems.